HarmonyOS is designed with a layered architecture, which from bottom to top consists of the kernel layer, system service layer, framework layer, and application layer. System functions are expanded by levels from system to subsystem and further to function a module. In multi-device deployment scenarios, unnecessary subsystems, functions, or modules can be excluded from the system as required. Kernel subsystem. HarmonyOS uses a multi-kernel design so that appropriate OS kernels can be selected for devices with different resource limitations. This subsystem provides basic capabilities for upper layers. Driver subsystem. Hardware Driver Foundation (HDF) lays the foundation for an open HarmonyOS hardware ecosystem. It allows unified access from peripheral devices and provides foundation for driver development and management. The system service layer provides a complete set of capabilities essential for HarmonyOS, including basic capabilities for all devices and capabilities dedicated to certain devices. This layer contains the basic system capability subsystem set, basic software service subsystem set, enhanced software service subsystem set, and hardware service subsystem set. The basic software service, enhanced software service, and hardware service subsystem sets can be tailored by subsystems, and each subsystem can be tailored by functions, depending on the deployment scenario for a particular device form. The framework layer provides what you need to develop HarmonyOS applications. Application framework and ability framework, specific to multiple languages like Java, C, C++, and JS. Java and JS UI frameworks, as well as multi-language APIs for hardware and software services. The APIs designed for different HarmonyOS devices vary according to component-based tailoring. The application layer allows you to develop applications powered by feature abilities (FAs) or particle abilities (PAs) based on the service logic provided by the framework layer. FAs and PAs are the basic units of HarmonyOS applications to implement specific functionalities. An application can contain one or more FAs or PAs. Their difference lies in that an FA has a UI, but a PA does not. For example, in a video call application, the main UI FA provides a UI for user interaction. PA1 collects videos recorded by cameras. PA2 beautifies the collected videos. And PA3 provides Super Night Mode. FAs and PAs can be downloaded, loaded, and run as required. Applications developed based on FAs and PAs achieve smart cross-device distribution of third-party services, delighting users with consistent and efficient experience. Take the video call application as an example again. When you download the application on your smartphone, the FA, PA1, PA2, and PA3 will all be downloaded. When you download the application on a smart TV that does not support beautification or Super Night Mode, only the FA and PA1 will be downloaded. This is the architecture of HarmonyOS.